Group 16 is working on the knee tracker device. For this project, we are developing 5 interactive Android games for common rehab exercises performed by patients recovering from knee surgery. Each of these games will have at least 3 levels of difficulty: easy, medium, and hard. These games will interface with Bluetooth equipment that was provided by our sponsor. Our sponsor is Dr. Shamim Sampath, a knee surgeon in London specializing in computer-aided knee surgery. The intent of these games is not only to track the patient's progress after surgery by recording range of motion of the knee and leg, but also to make the rehab exercises more fun in hope that the patient will be more likely to do these exercises. Our original scope included 10 games, 2 for each exercise, and iOS development. Due to unforeseen circumstances, we came to a decision, along with our sponsor, to only develop 5 games solely on the Android platform. The first exercise is lying knee flexion. This involves the patient lying on their back and sliding their heel towards their bottom, and then straightening their leg again. For the associated game, Ollie the octopus will move back and forth on a log to catch jumping fish. The larger fish are worth more points because they are further down the screen and require more range of motion in the knee to catch. Lying straight leg raise. The patient is again lying down and extending their leg up and down while keeping it straight. For the game, the patient's leg raises should follow Ollie's on-screen path. For more difficult levels, the range of motion of the leg is larger because the patient needs to lift their leg higher. Sitting circles. The patient is sitting with their knee at a 90-degree angle and creates circles with their foot. In the minigame, the circles they create will unlock the code to the padlock. More difficult levels have more notches on the lock and require more circles. Sitting full range quads. The patient is sitting with their knee at a 90-degree angle and extends their leg and then lowers it back to the ground. In the game, eggs will be released from the top right of the screen, and the patient will extend their leg and lower it to add eggs to the nest. Standing balance. In this exercise, the patient is to stand on one leg and keep the best balance possible. Similar to a bubble in a level, the object is to keep their core at the center for as long as they can. This game is still currently in development.
This was the original timeline for our project. The project was in an unfamiliar field, So at the start, our time estimates were little more than guesses. We fell way behind on this schedule. This Gantt chart represents our current schedule. This schedule was designed March 1st and is broken down based on the workflow we figured out over the course of this project. The Knee Tracker app category represents general infrastructure work to be done for all games, mostly modifications to the Android application we were provided. This is divided between the game launching functionality and the hardware integration. The remaining 5 categories are the 5 games and involve work both in Unity and in the Android application. Games are broken down into 5 milestones as listed: designed, playable on PC, polished, running on Android, and playable with the Knee Tracker. According to this chart, we are generally on schedule. Game 1 is running on Android, Game 2 is polished, and Game 4 is playable on PC. For this upcoming week, we are preparing to get Game 2 running on the application, Game 3 polished, and Game 5 designed. The only snag at the moment is in handling Knee Tracker input. There has been more difficulty than expected in getting the Bluetooth libraries working, so that task is expected to take more time than anticipated. This delays work on integrating the Knee Tracker with specific games. As of this moment, we have not yet had a chance to assess how much longer this will take and how this will affect our project timeline as a whole.
My name is Adam Kajowski, and I will be discussing our risk management plan. Currently, we've had 2 risks identified from our initial report materialize in our project. Not surprisingly, they were rated 2 of the highest in our risk exposure assessment. Risk 3 is concerning our short timeline to develop, test, and deploy our project, and Risk 5 identifies potential issues getting our knee tracking hardware to communicate with the software over the Bluetooth protocol. We've had a new risk that we're calling Risk 9 that materialized in recent weeks. Risk 9 was an unknown risk and concerns hardware and software compatibility, namely incompatibility between Android and the Unity game engine. What we discovered was that Unity does not currently support certain 64-bit processors in Android, specifically the ones found in most flagship smartphones. For example, the Qualcomm Snapdragon 845 and 835. Those are not supported by Unity. Since we've identified Risk 3 and Risk 5 before, our strategies for managing those risks remains the same. We will strictly adhere to our project timeline to mitigate issues with our shortened schedule. And we will also work through any hardware issues to help get a minimum viable product. While we have not had the support from the sponsor that we were hoping, Hugh on our team has been working very hard to help get us a usable product for our project. And finally, for Risk 9, we've resorted to using the emulators found in Android Studio to mimic the application running on a 32-bit processor. This will at least allow us to work towards completing the application, and our plan is to continue to try and use tools such as these emulators to help with any future issues.
The biggest realization we had over the course of this project is how effective it is to give individuals on the team ownership of sections of the project, especially in our case of a geographically distributed team with limited opportunities to meet with each other and get on the same page. The ownership provides autonomy between meetings and a clear distinction of who will be doing what. Once we broke things up this way, we made progress at a much better pace. Were we to start over, we would absolutely organize things this way from the start. The Scrum board is meant to give this distinction without requiring the project to be broken up, but it didn't work for us. It was hard to make clean distinctions of where one task ends and another begins, and on top of that, merging multiple edits to a scene in Unity is a problematic process. This specialization was particularly helpful, considering that this project is unknown territory for us. None of us started this project with any experience in Unity, but it doesn't really make sense for each one of us to expend the time to learn Unity when it only represents a portion of the project. Secondly, we learned the importance of pinning down a finish line. We had an issue for a while where we had multiple games stuck in a state of almost done, where new requirements would come up during each new demonstration. With proper communication and planning, this could have been avoided. We see now that it is important to agree beforehand what done means. Were we to do this over again, we would design a detailed mock-up of each game that would look exactly how the final product would, minus the interactivity. This would give the sponsor an opportunity to see exactly what we plan to make, and provide a time for feedback at a period where it doesn't cost development time. As it was, we jumped straight from the rough sketch to the full design of the game. This meant feedback arrived on the demonstration of the full game, and changes involved a reworking of design systems.